Okay, so after I left yesterday, you should have worked on part B, and then the rest of the page, although I'm pretty sure we probably got stuck somewhere around C and D. So let's walk through part B. Tell me how we would set up part B. How should we go about setting up part B? What pieces do I not know? And so they would have to be represented by variables. What pieces do I know? And so I can substitute in a value. We don't know the original price of the car. What were we using yesterday to mean the price of the car? P. Okay, so I have P times, do we know an R value here? Yes. I'm literally just recopying this down here and substituting in what we've got. So you said we have an R value. What are we going to put in for R? 0.0825. Tell me how you got that. Yes. If we take that and we divide it by 100, we get 0.0825. Let's scoot that over just a little bit. Have we talked in here about how you can remember to divide by 100 there? We've talked about percent being a compound word. Awesome. I always go back to that. If I don't remember, am I supposed to multiply? Am I supposed to divide? When they give me the percent, if it has the percent symbol next to it, that's telling me it's this out of, or for each, means division, cent, 100 cents in a dollar, so I divide. If I have the decimal and I want the percent, that's when I multiply by 100. All right, so I've got those pieces substituted in. You said we don't know the price, so I'm going to have plus P. What else do I need? Final cost, 16,368. So I'm going to rewrite the tax part of this by moving that number to the front so I see it very clearly as a coefficient. So I'm going to write this as 0.0825p plus how many other p's? Plus one other p is equal to 16,368. So far, so good? What can I do from here? Before I divide. Yes. These p's right here are like terms. So I'm going to add the 1 and that decimal together, and then I can divide. I'm going to combine it so that I have just a p in one spot. So I'm going to have to bring my work over here to do that. So that would give me 1.0825p is equal to 16,368. Now I can divide. I can't divide when I still have addition in that mix because I would have to divide every single term, so everything that has a plus or a minus or everything that's after the equal sign. If I condense it and I combine my like terms together so that I just have one term on the left-hand side, then I'm going to divide just that one piece. So far, so good? What are we dividing by? $1.0825 on both sides. And when we do that, we get the price of the car if she lived in New York. If our friend lived in New York, I don't know why I decided to make her female, but she is. If she lived in New York, the list price, the advertised price for the car would be higher or lower than if she lived in Arizona? Lower. When the tax rate is higher, they're going to add more on at the end. And so that means that advertised price would actually be lower than a state with low sales tax if your final cost is the same. What did you guys get when you divided? We want to take it out to 2 decimal places, to the nearest penny. You said 15,120? 0.55. Absolutely correct. You put 0.60? Honestly, if you are within a nickel of my final answer, I'm not going to get picky about it. Nobody's going to throw down at a car lot over a nickel. If we're talking about a pack of gum and you're off by a nickel, that's pretty close to the price of the whole thing. But on a car where you're talking thousands and thousands of dollars, I don't think 5 cents would make or break somebody on that. So I wouldn't count it wrong if you wrote 60 cents there, especially if you show your work and I can see your process all throughout. That would be fine. Okay, so for part C, what are we supposed to do on part C? I don't have it up on my screen, but you guys have it in your books. What are we supposed to do on part C? Find a state where the sales tax is R. We actually wrote this expression already. It's what we've been using since the beginning. This right here is what we want to put for part C. P times R plus P equals 16,368. So I'm going to copy that as is. And I'm going to paste it in right here. Apparently missing an equal sign there. All right, there we go. So far, so good? All right, that's all we needed on part C. That was it.
I did that, but then I saw.
Yep. Solving for R is just part D. So if you did it all in part C, that's fine. Just like draw an arrow like I did that here. So I'm going to take this right here. I'm going to solve it for R. Those of you that have already done that, this will be an opportunity to check your work. On all the other ones, we kept moving R up to the front because we usually knew what R was, right? So I'm going to go ahead and move R up to the front here. So I'm going to have RP plus, how many P's is this other one? 1 is equal to 16,368. We've been combining these two together because they're like terms, right? How do I add an R and a 1 together? Can I combine those? No, but I could put it inside parentheses because I know I would be adding those two numbers, and then it would have the P at the back.
Wait, why'd you put the R in front of the P again?
Because on the other two problems, that's where we kept moving it to. We kept moving that coefficient up to the front.
Oh, okay.
When we multiply two numbers together, it doesn't matter the order that we put them in. So it doesn't matter which order I have them in.
Okay.
I just moved it so that it was more consistent with the other work that we'd been doing. You guys okay with that so far? We're supposed to solve this for R. In part D, that means we need to get the R by itself. Where is the R right now? It's in the parentheses. If the variable that I'm trying to get alone is inside parentheses, anything that's outside those parentheses has to be the first to go. What's outside those parentheses? P. How am I going to get rid of the P? Divide both sides by P. Right now it's being multiplied, so we're going to divide by P. That'll make it cancel right here. So I would have R plus 1 is equal to 16,368 over P. I don't need the parentheses around the R plus 1 anymore because there's nothing else on that side anymore. It's just that. What do I still need to do to get the R all alone? Subtract 1. We're going to subtract 1 from both sides. So I'm going to have R all by itself here. Are the 1 and the fraction like terms? No, the 1 and the fraction are not like terms. So I would leave this as 16,368 over P, and then just tacked on the end, I'm going to have minus 1.
Why'd you put the minus 1 in the back?
Because I'm subtracting 1 from my fraction. I had my fraction first, and order of operations, if I actually had numbers to substitute in there, if I had a P in there, I would have to do that division first, and then I can do subtraction afterwards.
So we're always going to do that.
Here's one of the big key takeaways that I want you guys to get from this. We just solved for R. What is R again? Yes, this is our tax rate. If I wanted the percent, then I would take that and times it by 100. I can find the tax amount if I take the after-tax price, I divide it by the before-tax price, and I minus a 1 from it. Always, always, always. That works at the grocery store. That works when you're at an amusement park. That works anywhere, anytime. If they advertise, if you're like captive audience at the state fair, and they're like, get this drink for only $9. You buy the drink, are you only paying $9 for it? No. They charge a lot in taxes at those things, don't they? It's usually more than just your normal sales tax at those special events. Because they bring in out-of-town people, and they're like, great, we can get some of their money too. You can always find out what sales tax you are paying if you take the after-tax price and divide it by the before-tax price, and then minus 1 from it. Please make a note of that, because there are some questions on your homework that ask about this. You can always find the tax rate by taking the after-tax price, divide it by the before-tax price, and then minus 1. Your tax percent is equal to the tax rate times 100. Make sure you make a note of both of those pieces of information. That's going to be really important when you're working on that homework. So far, so good? Okay. Please let me know if you guys have questions. We are going to go and do the next page, page 117. And then as long as we get done with this in enough time, we're going to play a game. Right. Page 117 is talking about literal equations. They're called literal equations because what do you notice all these equations mostly have in them? Letters. Literal meaning using letters. We're trying to solve for one of those variables. In part A, what are we trying to solve for? H. To solve for something means to get it alone. I need to follow the order of operations as I'm doing this. If I have numbers and all I'm going to do is plug them into my calculator, that's when we start at the top and go down. When we are trying to solve for something or get it alone, we go backwards through the order of operations. What would I need to do to get the h alone here? Divide by w on both sides. Right now it's being multiplied. So if I divide, I can make it cancel. So I would have h is equal to a divided by w. This is an area formula. Multiplying the height and the width to get the area. A lot of times we'll say length and width, but this is if something is upright. We would have our height and our width. What do we want to get alone in the second one? W. Solve for W. That's the piece that we want to get alone. It's right here. We've got a couple operations going on here. I see the 2 in front of it. Yes, ma'am. Yes, we have to subtract the 2h first because when we're working on getting something alone, we have to get rid of any addition or subtraction that's near that variable before we can undo any division or multiplication that we see. So we're going to subtract 2h from both sides, and then we can divide by 2. So I would have p minus 2h equals 2w. I divide by 2 here. What do I divide the other side? Like which piece do I divide by 2? Do I divide the p by 2? Everything. The entire side. Not just one term or one part. We do it to everything. So w is equal to p minus 2h over 2. What is it that we want to get alone on part C? H. H is right here. Divide by pi r squared. Pi is just a number. Sometimes it's a scary looking number because it looks almost more like a variable there. It's just a number, like 5 or 7 or 2 or 3. So what would you do if it was a 3? You divide by 3. Since it's pi, we're just going to divide by pi. So divide by pi r squared. Do it to the other side. It's going to cancel this out. So h stands for height here. Does anybody know what that capital V stands for? Volume. The original formula. Anybody know what this is finding the volume of? Of a cylinder. This is the volume formula for a cylinder. Pi r squared, whenever you see pi and r, we're talking about circles, and then once you add a height to a circle, you get a cylinder. This is the formula for a cylinder. 2 more to go. You guys doing okay so far? Cool beans. What do we want to get alone in the next one? A. A is right here. If there's ever any addition or subtraction on the same side as what we're trying to get alone, we have to get rid of that first. Do you see any addition or subtraction? Yes, I see addition right here. So does that mean I subtract 1/2 at squared? No. Whatever I'm trying to solve for, whatever I'm trying to get alone, that stays put. I don't move that. I got to move the other pieces. So the V with the little 0 and the T, we read that as V not T. That's what we need to get rid of. Since that's a positive thing, I'm going to subtract to get rid of it. So I'm going to minus V not T from both sides. That little 0, I know I've talked about it with some of my classes before. The V here is standing for velocity. This is dealing with velocity and acceleration and position or height with respect to time. This is a physics formula. this is for projectiles, that V naught is talking about the initial or starting velocity.
Okay.
Divide
Like 2 squared.
by t squared. We can divide both sides by t squared. Okay. So that would give me in my numerator h minus v naught t over t squared equals 1/2 a. Have I gotten a alone? Yes, Cheyenne.
Can you move the 1/2 outside of that? Use parentheses, you know what I mean?
Sort of. If you see a 1/2, what operation is happening there? Division. How do I get rid of or undo division? With multiplication. So yes, we're going to multiply by 2, and I can put that on the outside of parentheses there. So I'm going to take this, I'm going to multiply it by 2, do the same thing to this side. So my 1/2 and my 2 will cancel. So A, the acceleration, is equal to 2 times the quotient of the height minus the initial velocity times time divided by time squared. It's okay to just look at it as a bunch of letters, but that's what all of those pieces are representing. What questions do you guys have before we go to the last one? We doing okay? Right, give me a real quick thumb check. Thumbs up, you're doing good. Thumbs down, you're doing bad. In the middle, you're like, eh. Cool beans. Okay. Last one. What do we want to get alone? Y. Where is Y? Both sides, top and bottom. Can I solve for it as long as I have 2 of them? I mean, not the way it's set up right now. I have to get them together, and right now they're on opposite sides of the fraction. I would really rather not deal with a fraction at all. What can I do to stop dealing with a fraction? We are going to multiply. I heard multiply. So we're going to end up with 2xy minus 7 on one side. I'm going to multiply both sides by my denominator here. What will that do to the left side? It's going to cancel out. So all I'm left with then is 2xy minus 7. What would I have on the right side after I distribute? 3xy plus 8. Did I get my y's together? No, but I got it out of the fraction, which is good. What can I do now to get them to the same side? We can add 7 to both sides. I really want to get my y's together. What we've done here is not wrong. 2xy equals 3xy plus 15. I don't want to divide. I want the y's on the same side. Subtract it. 2xy equals 3xy plus 15. Which one do I want to subtract? 3xy. I want my constants on one side together, and I want my variables on the other side together. Are these like terms? Yes, same variables. So what would I have then? Negative 1 xy equals 15. Last thing I need to do to get the y by itself. Divide by negative 1x. What is 15 divided by -1? -15. So is this going to be -15x?
No, negative 15 over.
-15 over x. I can simplify the numbers, but that does not move the x up to the top. We were dividing by x, so it's going to be on the bottom. All right, for our game. Sort of. I mean, yes, it's a math game, but it's not a math game you've probably ever played before. I want you to pick a partner. You and your partner need to come up here and get 3 dice out of the bag. If there's any numbers that you can't read on the dice, put it back and get another one. So you need a partner. Come pick 3 dice. You're going to roll those dice to create a 3-digit number. All right? So decide which dice represents your hundreds place, which die represents your tens place, which die represents your ones place. Come up and do that first, and then I'll go through the rest of the directions. So find a partner, get 3 dice. This is a 2-person game. I don't have a way to modify it to make it a 3-person game, at least not right now. I'm not that creative. Oh.
An entire fucking roach just crawled out of that notebook.
You.
It went to my backpack.
You.
Now I don't know what to do. I lost it.
I'll kill it. I wish I could say that that's the worst thing I've ever seen in here, but it's not. The dead mouse was worse.
At least that's dead. I know it's
All right. Okay. So after you have your partner and you have your 3 dice, you're going to roll them to get your 3-digit number. So 1 digit from each dice. One of you guys is going to be player 1, the other one's going to be player 2. Doesn't really matter which is which. Okay? All right. Whoever player 1 is, after you guys make your 3-digit number. Let me see. That one is a 9.
Okay.
Yep.
9, 1.
Okay.
On paper.
a dead one.
Lovely.
There's 2.
That's gross. Okay. Player 1, after you have your 3-digit number, you're going to take that number, whatever it is, and you're going to double it. Okay? So whatever you had on those dice, take it times 2. Then player 1, after you know what it is, after you take it times 2, you're going to pass that to your partner. So that becomes your partner's starting number. Okay?
So the other partner is not supposed to know what number you have?
No, they have to know. They have to know. So, for example, if I rolled my 3 starting dice and I got 3, 1, 2, that's my 3-digit number. If I'm player 1, then I would take that, 3, 1, 2, and double it. So that would give me 6, 2, 4, right? I'm going to take that and give it to player 2. So player 2's number is now 624. What does player 2 do with their number? Add 100 to it. So that would give them what? 724. Then player 2 says, cool, let me give that back to player 1. What does player 1 do with it? Doubles it. What would that give player 1 then? 1,448. Then they give that number to player 2, and you just keep going back and forth like that. The winner is the last person who writes down a number less than 1,000. Did player 1 write down a number less than 1,000? No, so player 1 lost right here. That means the winner is player 2. All right. Yep, right there. I want you guys to play several rounds of this and record those numbers, like who won and what was the winning number. Like what was it that did? Write down the starting number, sorry. So as you play these rounds, like my starting number was 312 and player 2 won. So I would say player 2, 312. And we'll record them up here, okay? I wrote the wrong thing on the next screen. I'll have to fix that.
What was the number first? Number that I got? The last number you saw? Alright,
All right. As you guys are playing back and forth, after you've gotten at least like 3 rounds under your belt, come up here and write down who won and what that starting number was. And I want to just get as much data recorded as we possibly can. I'll be right there. Oh, just scrap paper. Wherever, yeah, scrap paper. Now, when you roll these dice,
whatever I do, and I still have less than 1,000. Whatever I give is 1,000 more. What's the last one she said? I didn't get to read it. Well, what's the last one?
so player number 1 double click. Always. Player number 2 adds 100. That's it. So and after you add 100, we'll give it back to her. Take that number and double click. Go back and forth until somebody gets a number bigger than 1,000. As soon as you write down an answer that's bigger than 1,000, you're the winner and the other player is or you're the loser. The other player is the winner. Thank you.
240. Okay.
100. I have 840. What's played by 2?
You're not multiplying it. One of these is your hundreds, one of these is your tens, and one of these is your ones. So you could do 725. Oh,
Wait, is this your number?
Your turn.
Oh, the last one. I did not even choose. Now I'm cheating.
interesting. Thank you, gentlemen. Guys, I would love you to get at least 3 rounds played with your partner. And then depending on who's player 1, who's player 2, I want you to come up here and for each of those 3 starting numbers, because it doesn't take very long to lose. It's a very fast-paced game. You'll come up here, you're going to write down who won and what the starting number was all year round. So every group should add 3 numbers up here. We just want to collect a lot of data from us. Okay?
So I go up there and I write the numbers that you got. That I give you.
So she got 5, 6, 7.
Okay? So now she's going to open up at you. She's player 1. And you immediately lose. So that means by default you win. So with the number 568, you can put that for player 2, we write 568.
All right, all of them?
Write all 3 numbers and who was the winner. So if player 1 won 2 of them, and player 2 won 1 of them, is there a pin or do you just write it with your 840? Yeah, just write it with your finger. I have a stylus, but I don't like the way it sounds on the glass. So if you need to go back, yeah, just use the back arrow.
You probably can do it with your
Yeah, it's super touchy. I promise it's not a rigged game, but it's starting to look like it might be. Looks like the winner almost every time is who? Looks like it's player 2 almost always. We've got about 5 minutes until the bell. If you haven't recorded your numbers yet and who the winner was, please do that now. We'll pick up here tomorrow and we'll kind of analyze the situation and figure out where to go with it. All right? I know George for whiskey and I because my son works there and he likes to get like the spicy ones. Like it almost melts on your tongue. Yeah. I'm not sure. I just know that like my son works there, so he'll come home with it often. There was one time that they were getting rid of a bunch of it, and he's like, Mom, there's something there, there's something there. Oh my goodness. Okay. So just to wrap up before the bell, we'll take this data. We're going to look at some inequality behavior with it tomorrow, but we're going to use your data. You guys have a homework assignment that's due tomorrow. It's working with literal equations, like what we did right before we played the game. And it's working with stuff like the buying a car activity. Okay? You might be asked to find a price after taxes. You might be asked to find a price before taxes. You might be asked to find what the tax percent is. Any of those things are fair game. All right? It is due tomorrow. Please let me know if you guys have any questions. We are almost at the end of this unit.